Hello and welcome to the lesson on taxonomy, the science of classifying organisms. In this lesson, you should be able to recall the taxonomic levels, identify the different ways that scientists organize animals, and write a binomial name for an animal. Linnean Classification was a way of classifying organisms and a hierarchy based on similarities in physical traits, named after a Swedish botanist, Carl Linnaeus, in the 1700s. Taxa, a hierarchy of groupings, singular would be taxon. This sort of, another kind of key term that would be helpful is domain. A taxon that is larger and more inclusive than the kingdom level was added later. So this classification system worked, sort of, and for a lot of the animals today, it still works, sort of. Since then, most biologists agree that there's actually 3 domains of life on Earth: the bacteria, archaea, and eukaryota. We are going to be using primarily the Linnean classification system, but as a naming system, but as you'll see, the way they do that is also changing. And the system itself still works, but how the animals are being put into that naming system has changed. All right, so after Darwin published his theory of evolution in the 1800s, scientists started to look for a way to classify organisms. They started looking at the evolutionary history of a group of related organisms, what's called the phylogeny. It's represented by a phylogenetic tree, which we've got an example of right here. And so I'm going to take a couple slides here to go over phylogeny, but I have also got another lesson all about it. So if you're not getting it on this quick introduction, hopefully the follow-up lesson will help. But kind of real quickly here, when we look at species 1 and species 2, they have a common ancestor. Okay, so this phylogenetic tree is showing that relationship. Species 3 does not have a common ancestor individually with 1 or 2, but if we go back far enough, it does actually share an ancestor with what would later become species 1 and 2. Okay, so one of the things that we'll take a look at too is, again, the common ancestry, but also when we're looking at the kind of the root, we're looking at the past, farther back, and this one is going to be farther in time. I almost said future, but it's not looking in the future. That handwriting's not so great. So again, looking at species 1, 2, and 3, they're going to be farther in time in the timeline than this ancestor here or these ancestors there. All right, one way of classifying organisms shows phylogeny, that shows phylogeny is by using the clade. We're using a clade. A clade is a group of organisms that includes an ancestor and all of its descendants. Clades are based on cladistics, a method of comparing those traits in related species to determine ancestor-descendant relationships. And then they have those diagrams that are called, they use those clades to form diagrams called cladograms. So this cladogram represents the mammal and reptile clades. The reptile clade includes birds and shows that birds evolved from reptiles or had common ancestors with these reptiles. In the Linnean classification, Linnaeus classified mammals, reptiles, and birds, kind of groups that we generally recognize, but it doesn't show their evolutionary relationship. So here we can see that birds, going back in time, actually are another branch off from reptiles. And we can see that mammals and reptiles shared a common ancestor. So again, although we'll use the naming scheme from the Linnean Classification, and we're going to take a look at those taxonomic levels next, keep in mind that we also want to take a look at cladograms and phylogenetic trees to look at relationships, evolutionary relationships.